Welcome back to the class on electrical machines too. In this lecture, we are going to discuss about the slip torque characteristics of three-phase induction motor. Nothing but how the torque is developed in induction motor is depending upon the slip of the induction motor. Already we know that the slip of the induction motor is a function of a speed. Whenever we are giving a three-phase supply to the stator winding, the rotating field is creating from the stator winding that will be rotating. There is a rate of change of flux linkage with the rotor conductor. The current is passing through the rotor conductors. Whenever current carrying conductor places in magnetic field, every conductor experiences a force. All these forces collectively developing a torque at a shaft. Due to the torque, the rotor also will be rotating in the same direction of a stator. But the speed of a rotor never catches the speed of a stator flux as long as this machine is operating as an induction motor. Now here we have taken the S equal to Ns minus N by Ns. When N equal to Ns, nothing but when the speed of induction motor equal to synchronous speed, actually it is not happened. The slip of the induction motor becomes a 0 from this formula. When N equal to 0, then the slip of the induction motor equal to 1. As the speed of induction motor changes, the slip of the induction motor will be changes between the 0 to the 1. Now we have taken the torque developed induction motor T equal to K into S into U square RR divided by RR square plus S into X2 whole square. When the speed of induction motor near to synchronous speed, then the slip of the induction motor will be very low. When the slip of the induction motor is very low, the denominator quantity, this quantity we can neglect and compare to the RR square. Then we have this expression: torque is directly proportional to K into S into U square RR by RR square. All the parameters are constant except slip of the induction motor. So we can say very easily that the torque is directly proportional to the slip. As long as the slip of the induction motor is low, the torque developed in induction motor will be directly proportional to the slip. For a high value of the slip, nothing but when the slip is near to the 1, that is happen when the speed of induction motor is near to the 0. Now we are neglecting the RR square when compared to the S into X2 in the denominator. So if we neglect the RR square, then we have a torque developed in induction motor directly proportional to the K into S into V2 square RR by S into X2 whole square. S gets cancelled. So finally we have a torque is inversely proportional to the slip of the induction motor. Now we have taken the x-axis and y-axis. On the x-axis we have taken the slip. Here at this point you have taken the slip equal to 0. At this point you have taken the S equal to 1. At low value of slip, the torque developed in induction motor is directly proportional to the slip. This is the maximum value of the torque developed in induction motor. This is the slip corresponding to the maximum torque. After this, if you decrease the speed of an induction motor, then the torque developed in induction motor is inversely proportional to the, so that's why it is decreased. When the slip is increased, the torque developed in induction motor also will be increased. This region is nothing but stable region. This region is nothing but a unstable region. Where the slip is increased, the torque developed in induction motor will be decreases. We never operate the induction motor in this case, unstable region. At this point, how much torque is developed in induction motor? This is nothing but a starting torque. These are nothing but a slip torque characteristics of a induction motor. Now we are going to see the slip torque characteristics of a three-phase induction machine. Whenever you are saying the machine, nothing but we can operate that machine as a motor as well as a generator. Just now we have seen the characteristics of a three-phase induction motor, where the slip is lies between the 0 to the 1. Nothing but we are giving electrical input to the machine, so that this machine will be converting the electrical input to the mechanical output, which is available at a shaft. If you observe this diagram, The speed of a rotor is more than the speed of a flux. Now the slip value becomes a negative value. When the slip is negative value, then the same machine will be operating as a generator. But in this case, the speed of a rotor is more than the stator flux by means of an external prime mover. Prime mover is one which can give the mechanical input to the equipment. So by means of prime mover, we are running the rotor of induction motor more than the speed of a stator flux. By the time, the direction of the rotor current will be changes due to the transformer principle. The direction of the stator current also will be changes. Once the direction of the current is changes in the stator winding, then nothing but the current is passing in this manner. Now the stator is giving a electrical output. So from this equation, we can say very easily that S equal to Ns minus N by Ns. If the N is more than the Ns, then the slip becomes a negative. That is possible only by means of prime mover. We have to run the rotor of induction motor more than the stator flux the same direction. Then only the machine is giving a real power to the supply. But to create this flux, it requires a reactive power. So the reactive power will be taken by the stator of induction motor from the supply, but the stator winding will be giving the real power to the supply. Now we are going to see the characteristics of a three-phase induction generator, and S equal to 0 and S equal to M and S equal to 1. As long as the slip is operating between 0 to the 1, the same machine will be operating as a motor just now we have seen. This is stable region, this is unstable region. The same characteristic we are getting in the negative torque direction, but this is representing this is stable region. Again, this is unstable region. This region of operation is nothing but a induction generator, where the slip of the induction machine is negative. The same manner the torque also the negative. We are using the induction generators along with the wind turbine to convert the wind speed into the electrical power. This is one of the very important applications of induction generators. Next, double case induction motors. In case of squirrel case induction motor, we are keeping the one case on the rotor. In double case induction motor, we are keeping the two cases. This is nothing but a inner case. This is nothing but a black one outer case. So why we are going for the double case induction motor means there is some disadvantage in a squirrel case induction motor. It has a less starting torque, but it has a good running factor. But some loads requires a high starting torque. By the time squirrel case induction motor is not suitable. Suppose if you go for the slip ring induction motor, it has a good starting characteristics as well as running characteristics. But in some cases, it is not suitable. So that's why we change some design parameters on a squirrel case induction motor so that it can able to give the high starting torque. From this diagram, we can say very easily that the cross-sectional area of the outer case is very low. Nothing but it has a high resistance, low reactance. Inner case is designed such a way that it has a low resistance and high inductance. Squirrel case induction motor has a good running characteristics, but starting torque is poor. The slip ring induction motor has a good running characteristics and a good starting torque, but unsuitable for many types of applications. The outer case is designed for the high resistance and low inductance, and inner case is designed for the low resistance and high inductance. At the time of starting, the slip of the induction motor is 1, so the rotor frequency is very higher. Whenever the rotor frequency is higher, the outer case offers a low impedance when compared to the inner case. The outer case offers a low impedance when compared to the inner case, so the maximum current is passing through the outer case. The current always try to see the path of the low impedance. So the current, whatever the current is induced in the rotor, that will be trying to pass only through the outer case. Very little amount of current is passing through the inner case. but the outer case is designed with a high resistance, so this machine is giving a high starting torque. In running condition, the three-pole induction motor is almost near to the zero, very very low. So the rotor frequency is low. So the inner case offers a low impedance. This offers a low impedance because the rotor frequency is very very low. The majority of the current is passing through the inner case. The resultant torque is produced due to the inner case. It has a good running characteristics as well as the efficiency of the machine also will be more. Hence, the starting torque of squirrel cage induction motor can be improved by using a double case rotor to obtain the high resistance at a starting. Current flows through the outer case of a high resistance and the high torque is obtained. Characteristics of double case induction motor. We have taken the x-axis, on the y-axis we have taken the torque. Here s equal to 0, here s equal to 1. This is the characteristics of inner case. At the time of starting, see, equal to 1 is nothing but a starting torque developed due to the inner case will be low. But when you take the outer case, starting torque developed in a induction motor is very high. So resultant of these two, this is the black one. This is the starting torque developed in a double case induction motor. At every point of the sweep, if we add the torque developed in inner case and outer case, then we are getting the torque developed in a double case induction motor. This is the profile of the sweep torque characteristics of a double case. In this manner, we can increase the starting torque developed in a double case induction motor. Thank you very much. If you have any doubt, you can ask me directly or you can ask in the comment box of the YouTube channel so that I'm always welcome to answer all your questions.